In this video, I want to talk about loops or iteration statements. So these are structures in code and in C# that allow you to express a chunk of code that should be repeated some number of times. So this is where things are going to get interesting. We're going to be able to express a lot more complex things using loops. And to motivate this, let's think back to our trivia game that we were building. Every time you wanted to add a question to this application, you had to kind of copy and paste this template and then, update it to refer to your newest trivia question that you had. So this was okay when we had 3 questions, but imagine a game with 50 questions or 500 questions. That kind of copy and pasting would be absurd. And then if you had to go back and update anything, like change the ASCII art or add some color here, you'd have to do that in each place where you had a trivia question, which just becomes unmaintainable when you have like 500 questions in here. So loops will allow us to express this kind of repeating structure without having to do the copy and pasting. In the context of our trivia game, we're going to need loops are half of the puzzle. The other half is a concept called arrays or lists, which will allow us to store a collection of things. So we're going to dig into loops, which will get us closer to understanding how to update our trivia game. And then after loops, we'll talk about arrays and lists, which will give us the full picture. So just keep in mind as we're doing loops that we're going to learn some kind of like basic syntax, but it's going to be a little bit weird the first time we see it here. And it's going to involve a lot of stuff like counting, like printing out numbers. So that's just so that we can practice the basic syntax. And then as we add more concepts in, like we learn arrays and lists, we will unlock new features of our loop structures. We'll be able to do new and interesting things that we weren't able to do before learning arrays and lists. So I've got the documentation page from Microsoft pulled up here. We're going to do 3 loops, so while, for, and do in a new project. And for each will be one that we talk about when we add arrays and lists, because this is a looping structure specifically for going through collections. So while, for, and do are all these structures that allow you to execute a statement or block of statements while some expression, Boolean expression, is true. So this basic loop down here, it looks very much like an if statement, where instead of if, we say while. So we have our Boolean condition. And what happens is that as long as that condition is met, as long as this is true and is less than 5, this chunk of code will execute. And will keep executing as long as our condition is true. So I'm going to open up a new Visual Studio project here. And I'm going to put this with my other projects. And we'll call this Loops Demo. And this is going to be a really simple demo where we're going to do a couple of basic practice loops to get the syntax down. And in the next video, we'll actually use a loop to do something more real world. So let's start with our scaffold. We'll just using static system.console so that we can write line without having to say console. And let's say loops demo. And read key. And we'll press any key to exit. So if we run it, we should just have a basic template that we've used a couple times now where a title prints out on the screen, and then we have something that waits for the key to be pressed so that the console window stays open. And why don't we change the actual title of our console window to say Loops Demo as well. So let's write that first loop. Let's do a loop that counts from 0 to 10. And this will be a while loop. So we're going to need a variable like we saw here that we use in our condition. So this is going to be a variable that we have to define outside of the loop that then we can use inside of our Boolean expression. So it's common to create a variable called I for doing your looping structures. There's no special reason why we have to use that variable. We could call this number. We could call this count. So I think for some of these examples, I'll show you a few different variable names just to get the idea across that the name isn't special. So we're going to start this variable at the start of our range, and then we're going to set up a while statement that has our Boolean expression. We want this expression to be true as long as we are in this range. So we can say, well, count is less than or equal to 10, or we could say, well, it's less than 11. And then inside of our loop, we can print out the value of the count. And then really importantly, we need to make sure that we're changing our count variable so that it goes up by 1. So there are a couple of ways that you can do this. We saw in the documentation the ++ operator here, which will increment the variable. So we could say count ++. We can also say count plus equals 1, or count equals count plus 1. All three of these lines of code will increment the value by 1. I'm going to stick with this longer syntax. And the way that you can read this is from the right to the left. So it takes the current value of count, adds 1 to it, and then puts it back into our variable called count. So with that, we should have our first loop working. Aha! The count is 0, 1, 2, 3, 4, 5, all the way up to 10. It stops at 10. So the starting condition is here. Our ending condition is defined by our Boolean expression. As long as this is true, our loop will continue to run. And then we have, really importantly, this line here that makes sure that our count continues to go up each time this iterates. Now, if I forget that and I hit play, what I've got is called an infinite loop. So I have a loop that has started, but this condition can never be false. So our count started at 0. It's always less than or equal to 10 because we never bump the count up. So this is going to keep running indefinitely until the computer runs out of memory, or the Visual Studio has some sort of like debugging feature that detects the infinite loop and kills it. So this is an infinite loop. This is bad. This will eventually crash in some way. So when you have an infinite loop, your console window may be like printing something endlessly, or it may be sort of like freezing and not printing anything out. You can either hit the X or come back to Visual Studio and hit the stop to send a kill command to that console window. Let's take a screenshot here and bring this over to the whiteboard. And I was just removing the comments temporarily so that we didn't have those filling up our whiteboard. So we are going to have our while loop here. We will also see the do while loop and then a for loop. The way that you can think about how this loop runs is that it starts off top to bottom like we've seen before. So our int is created with a count of 0. Then our while is started, so this condition is checked, and then if that condition is true, everything that's inside of this code block runs, and then we end up checking our condition again. So the first time this runs, count is 0. This is true. 0 is less than or equal to 10. So it prints out 0, adds 1. Our count goes up to 1. And then we end up back here checking our while to say is 1 less than or equal to 10. It's true. So we print out 1. We add 1 to our count. So our count is now 2, and so forth, until we get to the place where our count is no longer less than or equal to 10. So inside of this structure, this bit is our Boolean expression. So just like what we were able to use in our if statement with a Boolean expression, we can use the same thing here. So our equal, our equality check, our greater than, less than, we can use our and or not operators to control the condition for our while loop. Any of those are valid here, as long as it's an expression that turns to true or false. And then because it's such an important structure, we can call this kind of our iterator statement. So this is the thing that takes our variable that's controlling the loop and kind of iterates it 1. So in this case, we're just taking that count and moving it up by 1, but we could be counting backwards. We could be counting by 2s, by 5s, by 10s. We'll want to have some kind of statement like that in most of our loops. And then so that we have it on the whiteboard here, if you have a variable, let's call it I, to increment it, you can say plus equals 1, plus plus will always increment it by 1, I equals I plus 1, and we have the same thing for minus. So we can say minus equals 1, I minus minus, I equals I minus 1. All of these will subtract 1 or add 1 to your variable. The top one here, the plus equals minus equals, and the bottom one here equals I plus 1 or I minus 1. These you can actually change. So we could say I plus equals 10 to add 10 to our I variable, or I equals I minus 5 to subtract 5. So the top form and bottom form are a little bit more flexible, and the increment and decrement forms here with the plus plus and minus minus will always just add 1 or subtract 1. As a little caveat, you'll also, I'm not going to go into this in this video, but you can do minus minus I. So there's the prefix and postfix version of the decrement, and same thing here for, you can say I plus plus or plus plus I. Let's take a look at the do loop now. So if we check out the documentation here for do, it tells us it executes a statement while a specific condition evaluates true. That sounds really familiar, but it tells us that the expression is evaluated after the execution of the loop, which means that a do while structure is going to look a little bit different. We say do, then we have our loop body here, and then afterwards we have our condition. This means that our do structure executes 1 or more times. It always executes once because this body, the loop body, is run before our condition down here is checked. So let's do a do while loop here. So we'll do one that counts backwards from 10 to 1. So do, and then we have our loop body, and then afterwards we have our condition. And let's use a variable called I this time. So we're going to start it at our starting place of 10, and then we can write line. The backwards count is I. And then we have to do this. In this case, we were incrementing count. Here we need to decrement. We need to subtract 1 from our I variable. So we can do I minus minus, or we could do I minus equals 1. And then we specify our condition. So here we're thinking about this end. So we want this to be true until we run through a value of 1. So we can say, well, I is greater than or equal to 5. 1 is what I meant. We're going from 10 to 1. And let's add a header here to print out while demo. And this will be our, where did I put that? Whoops, here we go. Do while demo, just so that we can differentiate those two in our output. So we got our while, and then our do while that starts at 10 and goes down to 1. And we could go ahead and add a new line here to give us some more space. So same deal, let's take a screenshot, bring this over to the whiteboard. And we're going to need a little bit more room. So our do is really similar to our while, except that the order that things execute is different. So if we think about this, we still start here with our I variable being set to 10. Then we encounter our do, which will have us run each line that's inside of here. Then we check our condition afterwards. And if that condition is true, we end up starting back at the top of the loop body here. So this will always run at least once, and our while loops can run 0 or more times. It's possible to write a while loop that never runs. Let me get rid, I think these lines are going to be a little distracting, so let's get rid of these. And let's do some different labels here. So this is our loop body, which is the same structure that we had over with our while loop. The curly brackets creates a code block that allows us to say multiple statements should be run inside of this loop. And then here is our Boolean expression. So that's it for our do while. It's really similar to our while, so hopefully not too crazy. The weirdest of the three in terms of learning the new syntax is a for loop, which this, again, executes a statement or block of statements while a condition is true, but the way that you express it is really compact. So it has this structure where you specify the initial condition or the initializer, then your condition, and then your iterator, your thing that increments or decrements or updates your variable after each loop. And then you specify the body below all of that. So a loop here that goes from I of 0 until I is no longer less than 5 and goes up by 1 each time is expressed in this structure. So this just prints out I, and it will print out 0, then 1, then 2, then 3, then 4, and then we are no longer less than 5, so we won't see 5 print out. And we can run this to see it over here. 0, 1, 2, 3, 4. So let's flip back to our code and create a for loop. And let's count from 5 to 35 by 5s. So we're going to create that for loop structure. The first thing we need is to create a variable here. I'm going to call it n so that we have a different variable from our previous loops. Started at 5. We need to then express our condition. So when should we stop? So I'm going to say we're going to keep going as long as n is less than or equal to 35. And then our iterator here. So what should we do to change our n variable after each loop? Plus equals 5. So it'll start at 5, go to 10, then 15, then 20, 25, 35, and then stop. And so we can write line counting by 5s. And let's also do this header here for demo, so we can distinguish this from the previous ones. Five, 10, 15, 20, 25, 30, 35. So let's do our same thing. We'll grab a screenshot of this and let's break it down on the whiteboard. Oh, shoot. I didn't mean to grab the right line. I just want the for loop here. There we go. So we can label this with those new keywords that we're learning, or new programming lingo that we're learning. This is our initializer. This is our Boolean expression, or our condition. This is our iterator. And here is our loop body. So we have a lot of the same parts. Like if we compare our do to our for, we've got our initializer here outside of the loop. We have our condition down here inside of the while. And then we have our iterator inside of our loop. So because this structure is really common, there is a syntax for that. That's what for loop allows you to do, is really concisely express your starting, your initializer, your starting place, your condition, and your iterator. So if we back up a step and look at all of these in context, they all allow us to do something repetitively. They have slightly different affordances though. So the while loop is something that you would choose if you have a loop that's running 0 or more times, versus the do while loop. This is something that is always guaranteed to run at least once. And your for loop structure is really good when you're like sort of counting from a starting place to an ending place. But I'll caveat all of that to say that basically you can express anything using any of these structures. We'll encounter different situations where one is our go-to over others. But in general, they are equivalent, or you can use them equivalently. One thing that I'll just briefly mention here too, while we've got the docs open, is that there are some more advanced things you can do with your loops. So if you go to jump statements, there is a break statement, which allows you to leave a loop early. So here we've got a for loop that goes from 1 to 100 by 1 each time, but as soon as you hit I equals 5, a break keyword has been inserted, and this will stop the loop early. So this is going 1, 2, 3, 4, and stops immediately upon encountering that break statement. So you can use break to leave loops early. You can also use continue to skip an iteration of your loop. So the continue keyword, when it's encountered, will just skip the rest of the loop body and head back up to the iterator in the case of our for loop, and then check the condition and run again. So here, this is using continue to skip every situation when I is less than 9. So even though our loop goes from I is 1 to 10, the output is only 9 or 10 or 9 and 10 because we are ignoring every iteration where I is less than 9. So those are some advanced things you can mix into your loops should you need them. What I want to cap this off with is we've seen some examples of while, do while, for that all have to do with counting. And at this point, we could write any of these loops using any of those structures. So we could rewrite this with a for loop. We could write this with a for loop. We could write this with a do while loop. They're kind of equivalent for what we're doing. And we know now how to sort of control how our variable is incrementing. We can add, we can count backwards, we can count by fives. But what I want to do is get away from counting, and let's do something that is closer to a real world situation that we might encounter. So let's do like a mini shop here. So let's say that we have a shop that we can print this out even. Welcome to the shop. And this shop has an apple and a banana. So this shop currently sells 2 things. If I run it, we should see these print out after all of our loops. I currently have apple and banana, and we can use a loop structure to ask the player, which do you want to purchase, and enforce that they can only pick A or B. So we can keep asking them this question, like I currently have these, what do you want? Until they pick A or B. And let's add our new line here so that this is separated from our previous code. So if we write this without a loop, we would sort of say the response is equal to read line, and then maybe we would trim and convert it to upper or lowercase. And we'd say if the response is A, we'll do one thing, else if the response is B, we'll, tell them go enjoy your banana. Otherwise, they pick something invalid. The problem with how we've written it currently is this runs once, right? If they choose something invalid, we can't prompt them again without copy and pasting all of this into our else or refactoring it to use methods. But now with our loop knowledge, we can actually use a loop to keep presenting these options until the player chooses A or B. So this is one of these situations where we have these 4 structures, while, do, for, and we can decide which one we want to use. We could technically use any of these to solve this problem. For, I would say, is not a good one because for is really well designed for doing this kind of counting. We're not really doing counting here. We're just sort of reprompting until we get a valid answer. Then we can think about while and do. Either of these would work, but we're in a situation where do is a really good choice. We're asking a question at least once, possibly more than once. So we'll wrap this in a do. And our condition will be something like while the response is not valid, we're using this Boolean variable to keep us in the loop. We will keep running this block of code, and it's always going to run at least once. If I just comment out our if statement here, we are printing this out, we're getting their response. If I hit play, we have an infinite loop because this is response is always false, but it'll prompt us multiple times. Let's see that in action here. I currently have, and then it's waiting for me to type something, currently have, and it'll just keep running. Let's start over with our if statement here. So what we want to do is say if the response is A or B, then we can sort of leave our loop. So if response is A or response is B, we could break to leave our loop here, or we could say is response valid is true. And if they typed in anything other than those, we can give them some feedback to say like, hey, I don't have pick something else. And I'm going to go ahead and put this in quotes. And we'll make sure that our is response valid is false here. So I currently have an apple, B, a banana. If I type in C, I don't have C, pick something else. I type in 1, pick something else, 23. But then as soon as I pick A, we're out of our loop. So then outside of our loop, we could say if response, oh, you know what? If we want to use our response variable here, so after the loop, we want to say like you purchased an apple or you purchased a banana, what we need to do is make sure that this isn't a variable that is local to this code block, because that's the only place where we can access response. We want to create our variable up here, string response, assign the value in here, and then we can use it down here. Response equals A, right line, enjoy the apple, else right line, enjoy the banana. And we could do this with an else if, but because our loop structure has now enforced that response can only be A or B, it's pretty much okay for me down here to just say if it's A, otherwise it's safe to assume that it's B. So I currently have apple and banana. Let's try getting it wrong. And let's try actually picking up the apple. Try it again, and let's grab the banana. Enjoy the banana. So this, we're not counting anymore. We're not doing the same thing we were doing here, but we're using that loop structure for something that's closer to what we would want to do in our applications so far, like make sure that a valid response has been given to us. So that's the basic syntax of the while, do while, for loop. That's an example of it out in the real world. What we'll do in the next video is actually take this into practice and make a little game, a little escape room game using loops.